So today we're going to talk about sequences. I'm sure that you have done them over the years, patterns, things like that. It's a real fun topic in elementary school. But now we start adding some algebra into it and working with some more sophisticated types of sequences. So what is a sequence? Well, all it is an ordered list of numbers. It's a little bit more than just being ordered. Usually there's a pattern to it that we do the same thing over and over and over. It is comprised of a bunch of terms, and all it is a number in a sequence. So when I show you an example in a minute, we'll talk about specifically what a term is. The types of sequences that we're going to talk about today are called arithmetic. Yes, it looks like arithmetic. It's where you put the emphasis. Arithmetic sequences. It's when you use addition or subtraction, usually addition, to get the next number. There is another type called geometric sequences, and that's when you use multiplication or division. There's something called the nth term, which sounds very much like algebra, because it is. It's a way, an expression, or a formula that you can find any term at any position in the sequence. So a common question might be like, blah, 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 find the 40th term in the sequence. And you're like, I don't feel like writing that out. But if you can find the nth term formula or the nth term expression, it makes it super easy to find that 40th term without having to write it all out. Okay, so let's look at some examples here. Example 1, I've given you 8, 13, 18, 23, 28. Now, the elementary schooler in you says, they all end in 8 and 3 and they keep switching. Absolutely true. But let's take it to the next level. The first term, the second term, the third term, etc. What do I do to get from one to the next? How do I get from 8 to 13? And then from 13 to 18? And then from 18 to 23, etc., etc. Each time, I'm adding 5. So the directions are going to say, describe the relationship between the terms in the arithmetic sequence. All right, well, the relationship is that it's increasing by 5. Sometimes we get really lazy and just say plus 5. Then write the next 3 terms. Now, if you don't feel like doing all the math, but you've discovered the pattern of 8383, super simple. The next 3 terms would be 33, 38, 43, usually with commas because we're picky. Okay, so describe the pattern. It is increasing by 5 from one term to the next. What are the next 3 terms in the sequence? This one, this one, this one. All right, let's talk about some decimals. Same idea. We've got 4/10, 6/10, 8/10, 1. The elementary schooler is going to say, it's counting by 2. And the sophisticated 7th grader is going to say, well, actually, we're adding 2/10 each time. Yes, with the fancy voice like that. So what is the pattern? We're going to increase by 0.2 or 2/10. Give the next 3 terms. Well, we're going to keep going. If this went 4, 6, 8, really kind of like a 10, then we're going to go to 12 or 1.2, 14 or 1.4, and 16 or 1.6. Now, this has shown us all of the terms in the sequence. We have not talked about the nth term yet. But what if I continued on and said, I need to know the 450th term? I really don't feel like writing out 449 numbers so that I can find out 450. All right, that's when we're going to get to the next part. I tried to squeeze this in to be on one page. I'm sorry. So the problem says that a greeting card company sells 5 boxes of cards the first week. Upstart, they're just getting going. They sell 5 boxes. But then as they track, each week they sell 5 more boxes than the week before. And that pattern keeps going. We want to know, we want to predict if that pattern continues, how many boxes they'll sell at the end of the 100th week. I don't feel like writing out 99 numbers. So let's use some math and yet let's use some expressions to figure this out. So the words that you're going to hear are position, the first, the second, the third term, etc. We're going to do some calculations and then the actual term itself. Okay, so let's say in week 1, we sell 5 boxes. In week 2, we sell 5 more than that, we sell 10 boxes. In week 3, we sell 5 more than that. We're up to 15. Now, if I had listed this out, 5, 10, 15, 20, you're counting by 5s. Yes. You're adding 5 each time. Yes. But that means I got to write everything out. So now let's work this way. How can I get from 1 to 5? Multiply. Right, you're going to multiply. Do you like my little kid voice? That would be you guys answering me in class. How do I get from 2 to 10? Multiply by 5. It's really funny, guys. It's even funnier in person. Sorry. How do I get from 3 to 15? Multiply by 5. And this is where the eye rolls start because the answer is the same every time. But what do you notice? This is staying the same each time. Every week, I'm just multiplying by 5. What's changing? The number of weeks. The thing that changes or varies is what gets your letter. So if I had to write a rule or an expression or an nth term formula, I would say this is 5W, where W is the number of weeks. So if I needed the 100th week, I could simply do 5 times 100. I predict if their pattern continues that at the end of the 100th week, they will sell 500 boxes of cards. Okay, we will do more of these. I kind of wanted to give you a little taste. You can do the rest of the sequences. That part's easy. If you think about the position in the order of the line, the sequence, and the number that's there, and figure out how you get from one to the other, and then look at what changes or varies, that's the thing that becomes your variable. All right, we'll do more in the coming days with these.